And on page 54, we are finding there zero index. So what is a zero index? A zero index we are going to consider. Remember we said index is always the power. So a zero index is that one where the power is zero. Okay. So we consider a squared divided by a squared. A squared divided by a squared, it gives us, if we first multiply, it will be a times a, then divide by a times a, and the answer is 1. But if we use the rules of indices, we have a squared divided by a squared. The base is a, here, even here the base is a. We shall just subtract the powers, and we shall have one base which is a, and the powers will be subtracted, so we have our answer as a to the power 2 minus 2, which is a to the power 0. So you see, the answer is the same when we use the rules of indices. The answer is a to the power 0. And when we multiply, the answer is 1. So what does that suggest? That simply suggests that a to the power 0, its answer is the same as the answer we got here, which is 1. So as we already know from our knowledge of primary, we are confirming that a to the power 0 is the same as 1. A to the power 0, the answer is 1. So in general, any number or expression with a power or index which is equal to 0, its answer will always be 1. E.g., 3 to the power 0 is 1, 150 to the power 0 is 1, a times b to the power 0, the answer is 1. So any number to the power 0, the answer is 1. So that is what we call a zero index, where the power is 0 and the final answer will always be 1. Okay, let us look at positive indices. Consider a product of numbers with the same index. A product of numbers with the same index. For example, a, b squared. What does this mean? A product of numbers with the same index. So the number is ab, but squared means you should multiply a, b times ab 2 times. So ab squared, this one, a b squared, it is the same as, it's like when you have 2 to the power 2 or 2 squared, the answer we get is 2 times 2. It always gives us 2 times 2, which is 4. So we are also saying here that if you have ab in a bracket and it is squared, actually this one should be in a bracket, this ab should be in a bracket, such that it becomes ab in bracket then squared. So its answer will always be ab times ab. But when you look at it, ab is the same as a times b. Even this ab here is also the same as a times b. So if we collect like terms, we multiply the a's first together, we shall have a times a, then multiply by b times b, which gives us a squared times b squared, and it is a squared b squared. So in short, a b squared, a b in bracket squared, the answer will be the same as a squared b squared. It's like bringing the squared inside. But you should not confuse it if there was any sign here. For example, if this was plus a plus b then squared, Don't confuse and bring the square again inside. I think we saw that when we were expanding and we understood it very well. There shouldn't be any problems here. So a b in brackets squared, we are concluding and saying it is the same as a squared b squared. Please take note of that. You don't have to write now. After the lesson, you can take the notes because you already have them. I believe you all downloaded the notes. Those who will still need the notes will send me a message inbox. I'll see how to help you. So similarly, if we have a out of b squared, it is the same as having a out of b. The a out of b is the number, so it is the same as this number multiplying itself 2 times by the same number. So a out of b squared will be the same as a out of b times a out of b, and it gives us a squared, a times a, because when we are multiplying fractions, we multiply the numerators together and the denominators together. So this is the same as a times a, which is a squared, then b times b, which is b squared. So in short, a out of b squared is the same as you bringing this squared inside. But I want to say something, that bringing this power inside to be on each number is only possible if you are dividing and multiplying like here. Please, if there is any sign of addition or subtraction, you must note that you must use the other method of expansion. So in general, this is what we have. A b to power n will be the same as having a, it will be the same as having a power n, then b to power n. I think this is okay from what we have seen. And a out of b to power n is the same as bringing the power inside a to power n out of bn. So this is simplified part. In general, that is what we get. Any question? Any question, members? Are we okay? If we are okay, Favor?
Yes. Yes, teacher.
Let us look at this together. Can you tell us what answer this one is going to give us from using this method that we have seen, this one here, the expansion that came from here? What do you think we are going to get here as our answer? If we had simplify that, you can give me the answer as you do in your rough book there. What answer are we going to get? Tell us.
6a cubed.
6a cubed. How are you getting 6?
2 times 2.
And you are sure that is 6?
It's 8a cubed.
Okay, thank you. That one is now correct. So let's thank Favor. It means we bring the cubed inside and the answer will be 2 cubed, then a cubed. And 2 cubed is 8. 2 times 2, 3 times is 8. Then so the answer is 8a cubed. Okay? The answer is 8a cubed. Juko. Juko save time.
Yes,
But
the answer is, the answer
first
is
tell us the expanded thing before you give us the final answer.
3 times 3 times 3 times 3.
How many times?
3 4 times.
Which is 3 to power 4.
Then y times y times y times y times
which is y to power what?
y is
The topic is indices. So I want the answer in powers, not multiplication. So 3 to power 4,
which is
that one I agree.
which is
What
3
will
to
be the
power 4 y power 6.
Nada. Olimba. How are you getting y to power 6? Okay. Yes,
Until y has a 2.
Y to power 2.
And plus the 4, which is 6.
Did we say that you add when you have 2 powers on a base? Because now y is going to have 2 powers. It is going to be y to power 2, then to power 4. Not so?
Yes.
So what is y to power 2? Cross bracket to power 4. That's the answer I want now from.
Which is, it is 3 to power 4 y power 8.
Good. That's what I've been looking for. So there you are talking. Yes, that, eh? Okay, can we give this to my namesake? My namesake. I only have one namesake in this group. Where is she? Ariho, where are you?
Chamilia.
What's the answer? Let's see. First, tell us the working, what you are suggesting.
Teacher, I think you say teacher, I don't know.
Now, you know, just multiply, yeah? Okay, let me guide you. The 2 and 3, they are just multiplying factors. So I want you to get 2 times 3, the answer is 6. Now deal with a to power 5 times a to power 4. What is the answer there of a to power 5 times a to power 4?
I think it's 8 power 9.
And 2 times 3?
6.
So the answer is 6, 8 power 9, as simple as that. So the answers are here. This is what Juko told us. The answer here, the 3, using this rule that we have just seen. Now our a is 2 and our b is a. So the power which is 3 will just come inside. It will be 2 to power 3, 8 to power 3, which is equal to 8a cubed. Then b will be 3 to power 4 times, now y will have 2 powers, y to power 2 like I was telling you, then to power 4. But when we have 2 powers like these ones, 2 and 4, on Tuesday we saw that we are supposed to multiply those 2 powers. So finally our answer becomes 3 to power 4 times y to power 8. Then this one, Sarah, I have been telling you, those with powers first bring them together, and those without powers bring them together. So it will be 2 times 3, which is 6, then times a to power 5 times a to power 4, and a to power 5 times a to power 4. The answer is 6a to power 9. The answer is 6a power 9. So I have another example here, and we are going to do it together the way we have done the other ones. We have 24a to power 6 times 5a to power 3 divided by 8a power 7. Let us do this together. Who wants to give us an idea? Put up your hand about how we should approach this. Nansubuga and Lisa, this thing
Yes.
is yours. Nansubuga, what do you suggest? Can you move away from that noise background, that music in the background? First move away. Yes.
We get the numbers alone and the letters alone, like 24 times 5 times 8 power 6 times 8 power 3 divided by 8 to 8 power 7. Then
Then
okay. Then we get the 24 times 5. Let me first work out. I think it's 120.
24
then
times 5
times 8 to the power. Yes. I think it's 120.
Yes.
Times 8 to the power 9.
Correct.
Divide by 8a to the power 7. First way. Let me work out.
You are correct.
Okay. Yes. Okay, I'm just thinking. Then maybe we get 100. Okay, we put numbers alone and letters alone. Then we maybe divide 120.
Just say we put indices alone. Yeah?
Yes.
And the other numbers alone.
Yes.
So we are going to first get 24 times 5 divided by 8. I think that's what you are suggesting, yeah? Then we multiply it by 8 power 6, 8 power 3, then divide by 8 power 7. But alternatively, since everything here we are multiplying, we can first cancel out this 8 and it can cancel with the 24. Thanks, Nansubuga. You had a bright idea. You are correct. So, alternatively, I was saying we can first divide and it becomes by 8, this is 1, by 8, this is 3. So, there is no digit in the denominator. So, it remains as 3, 8 power 6 times 5, 8 power 3, then divided by 8 power 7. So 3 times 5, the answer is 15. Then I pull out those with a's together. So let us first do this, all of you aside. Get a in your rough book, get 8 power 6 times 8 power 3 and divide by 8 power 7. So you realize that the base is the same, it is a throughout, then a throughout, so you add 6 plus 3, which is 9, and you are dividing, still the base is the same, So you will subtract the powers. So it will be 8 power 9 minus 7, and it will be 8 power 2. So finally the answer becomes 15 8 power 2. So there are very many ways of doing this. Like Nansubuga was suggesting, you would have first gotten 24 times 5, then divide by 8. Those letters alone or digits alone. Then you multiply by 8 times power 6 times 8 power 3 divided by 8 power 7. For us, let's note that when we are dividing and the powers are the same, I mean the bases are the same, we only need to subtract the powers. So this will be the assignment, but I will choose for you numbers to do from here. There is one who did all of them and sent it. That is okay, but when I give you assignment, first finish those ones that I have given you, then you ask me if you can do more. I will allow you and I will mark you outside class time, not doing everything. Okay. So let us look at negative indices. Negative indices, we consider an expression like 8 power 3 divided by 8 power 5. 8 power 3 divided by 8 power 5, you realize that the base is still the same. So we shall write the base, which is a, and divide, and we shall subtract the powers. So on the powers, we shall have 8 power 3 minus 5, and the answer is a power negative 2. Okay? 8 power negative 2. Now, alternatively, we know that 8 power 3 is the same as a times a times a out of a 5 times a. So what do we remain with? We remain with, if the 3a's cancel, even here 3a's on the numerator cancel with the 3a's on the denominator. Here on the numerator we remain with 1, and on the denominator we remain with a squared. So our answer will be 1 out of a squared. So we get 1 out of a squared when we multiply, and we get 8 power negative 2 when we subtract the powers. What does that mean? Since this one is the same as this, it means the answers we got here are the same. So from today and onwards, 8 power negative 2 is the same as 1 out of a squared. This is very, very, very important. 8 power negative 2 is the same as 1 out of a squared. Thus, 1 out of a squared is the same as 8 power negative 2. So in general, when we have a power which is a negative, the answer is the same as 1 out of the base and then the positive power. So it's like the inverse. When we have a power which is positive, power which is negative, the answer is always going to be 1 out of the base, then to power the positive number. That rule is very, 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 very important. For example, take note of this. I want to ask, using this rule, Jemima, what is 2 to power negative 3, for example?
2 to power negative 3 means that we
Louder.
get 2 to power negative 3 means that we put 2 out of, we put 1 out of, we put 1 out of 2 to power negative 3.
No. The, out of the denominator, the power will no longer be negative. It now changes to positive. Look at this. These two are equal. Yeah?
Yes?
The power changes. It will no longer be a negative. It will be a positive when you divide it by 1. Yeah? So
All
here
right.
we get 1 out of 8 power n. So can you repeat your answer here?
2 to power 2 to power 5.
No, you are wrong. Joshua, can you tell us what we get here? Using this rule, what is what is 2 to power negative 2? Where is Joshua?